So it's equilateral. Therefore, it's also isosceles. Therefore, when I want to find the altitude of this thing, h, I'm going to have to draw in that segment, right? Okay. Now, if the perimeter is 21, and this is a equilateral triangle, we realize that all these sides are 7, right? What is going to be that distance right there, then? Okay, give that to me in a better way so we can do math in an easier, more efficient way. 7 over 2. Okay? I think a lot of us are finding out in this assignment because the answers say leave as an exact answer. Okay? We never write like 3.5 radical something. Okay? We would prefer to write that as 7 over 2 radical something. And underneath our radical, we will never put a decimal if they're asking for an exact answer. We should have a better way of doing that. Okay? At least when I say never, I mean, 99% of the time. Okay? Occasionally, sometimes they take liberties every once in a while, and we'll put a radical underneath there just for a particular situation. But right now, I want to force us to work solely with fractions, no decimals. Okay? Because I think some of us are finding out that we're not that well adapted to being able to work with fractions, and that's going to cause you a lot of problems next year, the year after that, and the year after that. Okay, so force us to kind of work with those things. All right, we need to find h, correct? We need to find that thing right there. So the Pythagorean theorem is going to allow us to do this. So we should say that h squared plus 7/2 squared should equal 7 squared, right? That's the Pythagorean theorem happening inside that triangle. So that gives me h squared plus, now when I square a fraction, square top, square the bottom. Okay? And then it gives me 49. So now I'm going to solve for h. So first thing I actually have to do is solve for h squared. So it's going to be 49 minus 49 fourths, right? Now, if I'm going to subtract fractions, what do I need to do when I subtract fractions? Common denominator. That common denominator is going to be 4. Okay? So I need to put a 4 here. I need to multiply by a 4 there, right? So that turns in that top 4 times 49 is 196. Okay? That's going to give me h squared to be 147 over 4, correct? Okay. I'm then going to take the square root, so that provides h to equal radical 147 over radical 4, which radical 4 is what? 2. Now, radical 147, okay, 147, what number is going to divide 14? 7. Well, that also divides 7. Okay, so how many times will 7 go into 14? 2. How many times will it go into 7? 1. So 147 is the same thing as radical 21 times radical 7. Does that make sense? But radical 21 is the same thing as what? What two numbers multiply together to give me 21? 7 and 3, right? So can I write this way? Is 3 times 7 times 7, is that still 147? Yes. Why would I write it this way? What's going to happen right there? Yeah, that's a radical 49, so that comes out as a 7, left with radical 3 over 2. That number right there, that thing right there, is h. That's your altitude. All right? 7 radical 3 over 2. If that's my altitude, that's that right there. Okay? That has to be my base, doesn't it? And what was that length of that base? 7. It's just 7. If you said the base was 7 over 2, you're only finding the area of that triangle. We want to find the area of the whole thing, right? So you could do that red triangle and then double that. But I'm just going to use 1/2 the original triangle, which would be the whole thing, which is base of 7, and now times my altitude of 7 radical 3 over 2. Well, 7 is a fraction. So now I got 1 times 7 times radical 3. What's that give me up top? 49 times a radical 3, right? On the bottom, I have 2 times 1 times 2, which is 4. There's your area in an exact format for that equilateral triangle. Okay. So let's say I give you another equilateral triangle. And usually with equilateral triangles, the thing that we know about them is the side length. That's because we know that's equilateral. Does that make sense? So logically, we should probably have the value of the side length. Well, I want to do that again if I say, okay, well, what happens if the side lengths are 8? Or what happens if it's 12? Or what happens if it's 9? Or what happens if it's 2/3? Do you want to go through that process every single time? No, that's kind of messy, right? So what I'm going to do with you is that process one more time in a really, really messy way to show you something here. Okay, to show you maybe a quicker way of doing this. It's equilateral, so don't even worry about the perimeter being 21. If it's equilateral, let's say that the side lengths are S, S, and S. Would that make sense? Okay. Now, if I draw down that segment, what does it do to that bottom side? What is that distance going to be right there? S divided by 2. Okay. Now, in this triangle, can you find H? Can you say that H squared plus S over 2 squared is equal to S squared? Okay. So we have H squared plus S squared over 4 is equal to S squared. Is that okay? So this is the exact same procedure as what we did in the last one with specific numbers. But I'm going to move that to the other side. So it looks something like that, right? What do I need to be able to subtract these things? Common denominator. So it's going to be a 4, right? And isn't the top going to be a 4? So that's going to give me 4 minus 1 gives me 3 S squared all over 4. And that should be what H squared is equal to, right? So if I take the square root of both sides, square root the H squared, and then square root this thing, okay? Well, when I square root, I'm going to write it in its entirety first. So that's what I have. And let me change the thickness of the pen so you see it a little bit better. So the square root of 3s squared over 4. Okay? Is that the same thing as the square root of 3s squared over the square root of 4? Is that the same thing as the square root of 3 times the square root of s squared divided by the square root of 4? Okay? What is the square root of s squared going to give you? S. Square root of 3 is just square root of 3. That doesn't simplify at all. What's the square root of 4? 2. There's h right there. That is this thing right there. Does that make sense? Okay. So now can I find the area of this whole triangle? Because I know the base. I know the base was s, right? And now you know h. So let's go. Area is 1/2 BH. But your B is S. So write as S over 1. And your H is S radical 3 over 2. If I multiply that out, what's 1 times S times S? S squared. Times radical 3. And what's 2 times 1 times 2? 4. What we just found is the formula for the area of an equilateral triangle. Think about what we came up with the first time. We came up with 49 radical 3 over 4, right? that formula, does that produce 49 radical 3 over 4 if you know S to be 7 in our problem? Okay? So you see how the benefit, you would not want to go through that process every single time as S changes, right? So we make S arbitrary, go through that process, and it generates a formula that now all we have to do is plug S into that formula, and it generates that area right away. Okay? So that is it's a special formula for equilateral triangles. It only works for equilateral triangles. Okay? It will not work for anything else. But you see how it's kind of a time saver. Okay? So if you want to use it, that's fine. Okay? If you want to go through that long process, that's fine as well. Think about taking a quiz or a test, though. If I want to go through that long process, that's going to chew up some time, right? Okay? So somehow maybe I need to find elsewhere that I can save some time. I know many of us are struggling with, subtracting fractions, multiplying fractions, square roots, adding fractions, that kind of stuff. We should be way beyond that, guys. Okay, and if you're struggling with that, many of us, the reason we struggle on it is because we use our calculator too much. We rely on that too much. Okay, stop relying on that, and you're going to develop your skills a little bit better. All right. If I sprain my ankle and I get on crutches and I use those crutches for the rest of my life, my ankle's not going to get stronger, right? Okay, I got to get rid of the crutches to do something. Okay, to strengthen my ankle. So it's the same idea with your calculator. Don't let it be a crutch. Let it be a tool. All right, so this one's a rhombus. We did this one yesterday, right? Or something similar to it. I don't know if I've got, there we go. Rhombus tool here. All right, so if the side lengths, the perimeter is 52, what is each side length? 13. Okay. I'm going to need that diagonal, and that one's probably the one that they're saying is 10, right? So I'll call the red one D1. Let's just say it's 10. I also need the other diagonal, so I'll make it blue. That's the one we got to do a little bit of work to find. Okay? But we know that the diagonals are perpendicular to one another, correct? What else do they do to one another? They bisect each other. So this distance right here, okay, that distance there should be what if the entire diagonal is 10? 5. You told me the side lengths were, the side lengths of the rhombus were 13, or those are the hypotenuses of that right triangle, correct? Okay. So what I'm looking for to find this distance here, let's just call that distance maybe x. Would you guys agree that x squared is going to equal 13 squared minus 5 squared? So it gives me x squared is equal to, that's 169 minus 25. That's 144, right? So x is 12. All right. 5, 12, 13, that's it. That's a common Pythagorean triple. Okay. So if that little distance x is 12, what is diagonal number 2? 24, good. So then can I say that the area of a rhombus is 1/2 d1 d2? So 1/2 times 24. Half 24 is 12, right? 12 times 10, then that's going to be 120. Hopefully, going through yesterday's questions would have helped you with that one. I think we end up seeing that one enough that we will eventually get pretty proficient at these rhombus questions. Now, question 3 is very similar to one that we did yesterday. Okay, the one we did yesterday, the circle was on the inside of the square, right? Where's the circle on this one? Outside the square. So we're going to take a square here. I don't know if my PowerPoint abilities are going to be very good here, but we'll see. All right, so that's the idea that we're thinking about, right? Okay, let me bolden these a little bit for you. All right. Now it says that the radius of the circle is 7, correct? Radius is 7. Describe to me where the best place to put that radius would be. Okay, good. So one of the corners or vertices of your square, right? That would be 7 right there, right? Okay. Now, what are you going to do? If we know that the area of a square, the formula that most people kind of commit to memory is that it's s squared, right? But it is also BH because it's a rectangle. Okay, good. It's also 1/2 D1 D2. And it's also 1/2 AP. Okay. Why is that one best? Yeah, you have half that diagonal, right? So that diagonal is going to, or sorry, that finished part there, or the rest of the diagonal is going to be 7 as well, right? So D1 is going to be what? 14. In a relationship or a property, it's not really that hard to see or realize if you didn't remember this property, but the diagonals of a rectangle are congruent, right? No, not rectangle. The property is defined as the diagonals of a rectangle are congruent, but a square is a rectangle. So the diagonals of a square are also congruent, right? Okay. So D1 and D2 are both 14. So then I take 1/2, 14 times 14. Good. Okay, so 7 times 14. Or I take 196, because that's what 14 squared is, right? And then multiply that by 1/2. Okay, and I think personally, I think I see that a little bit better. 98, right? Okay. Are there other ways of doing that? Absolutely. Okay. Are there other easier ways of doing that? I don't think so. Okay. I think the other ways are going to involve you recognizing, if that's total of 14, is this a 45, 45, 90 triangle here? So does that make that side of my square 14 over radical 2? Divide by radical 2 to get my side lengths. If I take 14 radical 2 as or 14 divided by radical 2 as my side length, I say area is equal to 14 divided by radical 2 squared. So that gives me 196 over 2, which is the same thing that's saying. Okay. Obviously, there's other ways. There's because of all these formulas, but to find the components of those formulas might be a little bit more work than what's necessary in that problem. This one, does it matter where the sides are? No. Okay. That is a common question. Is you said the sides are 6 and 10. But how do I know which one's which? Okay. Well, if you weren't certain at home, what could you have done to determine that? Yeah. Try both ways. And if the answers are different, then yes, it matters. If the answers are not different, it doesn't matter, right? In this case, it does not matter. All right, so if this side, let's say this side here is 6, and that side there is 10. Okay, obviously when we draw this is probably the 45-degree angle, right? Okay. Is this the same problem we had yesterday? I just didn't give you the picture, right? You had to generate it yourself. You got to find that h. So isn't that, this is my n radical 2 side, right? So 6 over radical 2 would be h, right? Okay, so area is BH. So we're going to take 10, because that's the base that the 6 over radical 2 is drawn to. And I think we even saw these numbers yesterday in one of the problems. So I rationalize that into something like that. What's going to happen with the 60 and the 2? Good. So we get 30 radical 2 as that area. But now the question was, are they different? Does it matter where the side lengths are? Now when we move around the side lengths here, with that, honestly. There we go. All right, so if I move the side length, so this one becomes 10, and this one becomes 6. This distance here would be 10 divided by radical 2, correct? Okay. So now when I do the area formula, B is 6, H is 10 over radical 2. Does that still give me 60 over radical 2? Okay. So if it still gives me 60 over radical 2, then obviously I'm going to rationalize that the same way. So I get 30 radical 2 in my answer. The next one is the same thing. The exact same process. However, not a special right triangle, right? Okay, it's a right triangle with a 52-degree angle in it. Once we construct that that altitude, so let's see here. Let's draw that down. Got that right angle. Okay. I still need to find that H, right? Well, if I look at that triangle, just going to draw it here so it's a little bit bigger. If that's 52 degrees, okay, and you know this side length here is what? 6, because that's a 6, right? You got to transfer that over here. Opposite sides of parallelogram are congruent. Okay. What side is H and corresponds to 52? Opposite. What side is 6? Hypotenuse. Which trig ratio? Yeah. Sine incorporates opposite and hypotenuse. So I say sine of 52 is equal to H over 6, right? Multiply both sides by 6. And there's my H, okay? So now that's a little bit different looking than what it was in the last question. The last question, I think the hypotenuse, or not the hypotenuse, the altitude was 6 divided by radical 2, or 10 divided by radical 2, one of those, okay? Well, that's a rational number divided by a rational number, right? Rational divided by irrational. Or division is the same as multiplication, it's multiplying by reciprocal, so we can still view that as multiplication, because that's what we got going on here, right? We got number times a number. Does that make sense? Okay? So I don't need to transform that into anything else. It is exactly the same concept as what the last one was. Okay? In the last example, you had H as a quotient of two numbers. Here you just have H as a product of two numbers. Leave it as that. Okay? Those numbers don't work well together. Okay? So we just imply the multiplication. What is the area formula for a parallelogram? Base times height. Okay? So I'm going to take base. What's my base in this case? 13. I'll multiply it by H instead of height, but we should say altitude, right? Multiply my base times my altitude. So my base is 13. My altitude is 6 sine of 52. And we've talked about this several times. That is a number, obviously. That is a number, obviously. And those are, right now, those are, you want to view them as rational numbers or integers, because they are both those things, or whole numbers. They're both those things, or all three of those things. But that is unlike those two, right? Okay? So we're going to multiply the two that work together the best. And that'd be 13 and 6, right? 13 times 6 is 78. And then that doesn't work well with that other number of sine 52, so we just imply the multiplication. That is our exact area. Okay. Now, obviously, if you want to change that to a decimal because of the context of what the problem is or why you might need it as a decimal, feel free to do that. If I ask it as an exact value, that's the way we do it. Because once I type sine 52, that is most likely an irrational number, right? Okay. And I would have to cut it off at some point. Maybe it's not irrational. Maybe it's just an ugly rational number. Okay, so I'll cut it off at some point. Is that okay with everyone? Okay. Do we need to do this one? 6? Right. Okay. So we did one yesterday. I had an 8 there, and that's a great thing to kind of recognize, guys, as you're going into other classes. Use your previous content, your previous examples to mimic the ones that you're working on for homework. Okay. This one might have been a little bit more difficult. Okay. I've seen people try to chunk this up into a rectangle and 2 triangles and add those together. Absolutely fine. More time consuming, but it is fun. It works. Okay. Let's take this and address it with our formula for a trapezoid. Okay. Guys, remember the area formula for a trapezoid? Okay. So area is 1/2 h b1 plus b2, right? Okay. And the 1/2, the h, and the b1 plus b2, that product, or sorry, that sum, these can be rewritten because of the commutative property. It can be 1/2 b1 plus b2. Put your h out here. Okay. However you want to write those things, they're all the same, right? Okay. Most time in a textbook, I think you're going to see it probably written that way. So now we got to find those things. We got b1 plus b2, don't we? Yeah. And that's something to think about as you guys are trying to use formulas for this class, other classes. I think it's especially the case in the science class, is that I start writing down the things that I know, and then it opens my eyes to things that I don't know, and that's what I then have to use my properties and logic to kind of figure out. So I got to find h, right? I got to find the altitude. Okay. So what is, anybody know that altitude? It's 4. Okay. Now, how do we get that altitude? Yeah, I think your approach is perfectly fine. But I think maybe the easier thing to do is when we drop those out, we drop both those altitudes down. What is this shape here? It's a rectangle, right? And if that 6 doesn't, that distance right there have to be 6. Okay. Now, if that distance, that red distance is 6, what are these two going to add up to? These blue distances. They have to add to 6. Now, do I know how they add up, or how each one of them is? Okay, it's 3 and 3, right? But how do I know that? How do you know that? Okay, because it's an isosceles trapezoid. So that tells me that these two triangles are indeed, because that's the same as that, right? That is the same as that, correct? That is a right angle there. That is a right angle there. These two triangles are congruent by hypotenuse leg, okay? And that then tells me that this blue segment here is the same as that blue segment there. If this number was like 5.1, I can't make that argument. Does that make sense? Okay. So that is indeed 3. So then, if that's 3 and that's 5, what's the... Yep, it's got to be 4. That's the third component of that Pythagorean triple, right? Or just use the Pythagorean theorem to generate that. So h is 4. So I have 1/2 4 times 18, which ends up giving me 36. We're good with that? And the next one was a doozy, right? So again, here we still have the 1/2 h b1 plus b2 idea. Okay. Do you know h? From the picture, from before we do anything, do you know h? Do you know b1? Okay, so I know one of these, maybe that's b1, right? Okay. Do I know b2? No. Okay, I know it's bigger than 37, but I don't know what it is specifically. But this is an altitude, and I put these in here for you. Sometimes you're not going to see those drawn in, so we got to know those are the best 2 spots to draw your altitudes that you're going to need for these things. That's a right angle. What's that make this angle up here? 45. Okay. Do we have the ability to recognize what that blue distance right there is? 37 minus 14. Okay? Because if I take this 14 right here and transfer it down here on this 37, okay, remove that from the 37, you get 23. So that distance there is 23. Why did I need to know that? Doesn't it provide me that? Because it's a 45, 45, 90 triangle, so it's isosceles, so that is 23. Why is that useful? It gives me that, doesn't it? The altitudes are the same in this figure. So now why all that stuff, transferring all those values using these properties, gets me now to this being the inside in a 30, 60, 90 triangle, correct? So what is this distance right here, which is across from your 60-degree angle on a 30, 60, 90? What are you going to call that? 23 radical 3. Okay. So, start filling some stuff in here. We know 1/2 h is 23, right? And b1 plus b2. Well, b1 was 14, correct? Plus then b2 using the segment addition postulate is those two things added together, right? So it's 37 plus 23 radical 3. All right? That is the answer. It's not in a reduced form yet. But we got to realize what we're allowed to kind of work with here. Okay? What components relate well with addition? Would you guys agree that I can add that number and that number together? Can I add those to this number? No. The only way that you guys can add, if you guys go back to your rules for adding radicals, a radical b plus c radical b is a plus c radical b. You add the numbers out in front, okay? But a radical b plus c radical e is equal to a radical b plus c radical e. If the numbers underneath are different, you cannot add them together. Does that make sense? Okay? So, because these have no numbers, no radicals, okay, we can't add them with something that has a radical attached to it. Does that make sense? Okay. So, 14 and 37 add to give me what? 51. And then I still got my 23 radical 3 being added to that. Okay. Now I am looking at this 1/2 and this 23. Do they work well together? Not really, because this one's odd, right? If it was even, yeah, I'd run that 1/2 through that number, and if it was 24, I'd run that through and get 12, right? And that'd be a nice number to have. So I'm not going to deal with the 1/2 right away. I'm going to actually see if we can look at just this stuff. If you have a monomial, a single value, single term, times a binomial, you got to distribute. Good. Okay. So 23 times 51 was that 1173. Okay. So 1173 when I distribute. And then 23 squared is 529. And I got radical 3 there. Okay. So that is distributing that there into there. Still got that 1/2 out in front, right? Can I multiply this number by 1/2? Can I multiply this number by 1/2? All right. So you can write that way. That would be fine. If you want to write it as a more condensed way so that there's only one denominator, because they are the same, you can do it that way. But that is the best answer because there's no rounding there, right? Okay. Now, if I allowed rounding, are you done almost instantly once you write 1/2, 23, parentheses, 14 plus 37 plus 23 radical 3? You just type down your calculator, right? Okay. But if we do that, we circumvent all that practice and getting better at our algebraic skills, which we need to get better at. Okay. And when I say we, I'm including myself in that. Does that make sense? Okay. I might have a bachelor's degree in mathematics. I've been teaching it for 12 years. I got 18 hours of graduate courses, but collectively, I still suck at algebra. Okay. Because I can always get better. Does that make sense? Okay. You've got your great athletes, your great singers, whatever. I bet if you ask Bryce Harper or Mike Trout, those you don't know, those are like the best 2 players in baseball right now. They would personally think or say, there's a lot of things in this game that I could get better at. Okay? Go ask Beyonce or Jay-Z, are there things that you could get better at? And they'll say yes. In the music industry, there's a lot of things I could probably get better at. So you guys can kind of take that into every aspect of your life. If you're great at it, okay, you can probably get a little bit better at it. Okay? Just keep those things in mind as we progress through the rest of high school.
I was the first to do that top of your head.